Hi and welcome back. So in the previous session, we introduced the concept of nominal and real interest rate. We also made a distinction between these two concepts and also outlined the relation between nominal interest rate, real interest rate, and inflation rate. So in this and the next session, we are going to build up on this distinction and revisit the effect of money growth on interest rate. So we do this by revisiting the concept of the IS and LM model. So in the IS and LM model that we developed in chapter 5, the interest rate came into play in two places. It affected investment in the IS relation, and it affected the choice between money and bonds in the LM relation. So the question we seek to answer here is, which interest rate were we referring to? Is it the nominal or the real interest rate? Okay, so take the IS relation first. So our discussion in the previous session makes it clear that firms, in deciding how much investment to undertake, care more about their real interest rate than they do the nominal interest rate. So firms produce goods. They want to know how much they will have to repay, not in terms of rents, but in terms of the goods they produce. So what belongs to the IS relation is the real interest rate. And therefore, the IS relation as we know it is going to be adjusted a bit. And the interest rate that was I is going to be changed for R, as shown in this equation 14.5. So the modified IS relation now tells us that investment spending and thus the demand for goods depends on the real interest rate. Okay, so turning to the LM relation. When we derived the LM relation, we assumed that the demand for money depends on the interest rate. But we were referring to the nominal rate or the real interest rate. So this is what we seek to answer here. So the answer is that we were referring to the nominal interest rate. So if you may remember very well, why did the interest rate affect the demand for money? So when people decide whether to hold bonds or money, they take into account the opportunity cost of holding money rather than bonds. So the opportunity cost is what they give up by holding money rather than bonds. So money pays zero nominal interest rate. Bonds pay nominal interest rate of I. Since we said we use I to denote nominal interest rate. Therefore, the opportunity cost of holding money is equal to the difference between the interest rate from holding bonds minus the interest rate from holding money. So the interest rate of holding bonds is I minus that of holding bonds, which is 0, which will take us back to nominal interest rate. This then means that the LM relation is still given as it was before. It doesn't change. All right. Okay, now that we've made that clear, the next step is to put the IS and LM equations together, as well as the relation between interest rate and nominal interest rate and real interest rate. So putting together the IS equation up here and the LM relation, as well as the relation between the real interest rate and nominal interest rate, as well as inflation, gives us an extended IS-LM model, which is given by all these three equations. So the immediate implication of these three relations is that 1, the interest rate directly affected by monetary policy is the nominal interest rate. In other words, the interest rate that enters the LM equation is the nominal interest rate. 2, it tells us that the interest rate that affects spending and output is the real interest rate. So in other words, this means that the interest rate that enters the IS relation is the real interest rate. So the effect of monetary policy on output depends, therefore, on how movement in the nominal interest rate translate into movement in the real interest rate. So we explore these relations further by looking at how an increase in money growth affects the nominal and the real interest rate, both in the short and the medium run. So the question we seek to answer here is that, does higher money growth lead to lower or higher interest rates? The results will show that higher money growth leads to lower nominal interest rate in the short run, but higher nominal interest rate in the medium run, as well as the fact that higher money growth leads to lower real interest rate in the short run, but has no effect on the real interest rate in the medium run. So in essence, the answer to our question is both, and we'll show why. So the first step is to revisit the ISLM model. So as we've just saw that we have derived 3 equations, the IS relation, the LM relation, and the relationship between the real and nominal interest rate. It will be more convenient to reduce them to 2 equations. To do so, we replace the real interest rate in the IS relation by its expression of this equation. Therefore, the IS relation is going to change in this session, and real interest rate will be given by nominal interest rate minus expected inflation, such that for a given expected inflation, nominal interest rate and real interest rate move together, because if this is given, the change in that is going to affect that 1-for-1. The LM relation, on the other hand, doesn't change. It's still the same as it was in chapter 5. So it tells us that given money stock, an increase in output, which leads to an increase in demand for money, it requires an increase in the interest rate. So the associated IS and LM curve are drawn in this figure here, which tells us that for the given values of price, nominal money, government spending, and tax, and for a given expected rate of inflation, the IS curve is still downward sloping, as shown by this. So for a given expected rate of inflation, the nominal interest rate and the real interest rate move together, as we've just explained. So a decrease in nominal interest rate leads to an equal decrease in the real interest rate, leading to an increase in spending and output. So the LM curve is upward sloping, as you can see here, which tells us that given money stock, an increase in output, which leads to an increase in demand for money, requires an increase in the nominal interest rate. So the equilibrium is at the intersection of the two, as indicated here. So where the IS curve and the LM curve intersect, and it's represented by point A, with output level being at equilibrium at YA, and nominal interest rate being at equilibrium at IA there. So given the nominal interest rate, the real interest rate is given by this equation. So RA is equals to nominal interest rate minus expected inflation. Now, what happened to this economy in the event that there is a there's growth in money? So assuming that the economy is initially at the natural level of output here at YA. So let's assume that at YA, the output is equal to its natural level. Now, suppose the central bank increases the rate of growth of money. what happens to output, to the nominal interest rate, and to the real interest rate in the short run. If you may remember very well, one of the lessons from our analysis of the monetary policy in Chapter 5 of our Macroeconomics 2 module is that in the short run, the faster increase in nominal money will not be matched by the equal increase in the price level. So in other words, the higher rate of growth of nominal money will lead in the short run to an increase in the real money stock. So from this equation, so this narrative is from this equation, that the two will not grow at the same time, or will not be, the increase in one increase in nominal money M will not be matched by the increase in the price level. Therefore, the whole money stock will increase. So money stock is represented by the entire fraction, which is nominal money over price. So this is all we need to know for our purpose in this section. So now, what happens to output and to interest rate in the short run is shown in this figure 14.4. And the first effect is that the increase in real money stock causes a shift in the LM curve downwards. So from this LM to this one, indicated by this arrow here. So this tells us that for a given level of output, the increase in real money stock leads to a decrease in the nominal interest rate. Hence, the nominal interest rate has decreased as shown here. So if you assume, as seems reasonable, that people and firms do not revise their expectations of inflation immediately, the IS curve does not shift. It stays the same. So this is justified by that given expected inflation, a given nominal interest rate corresponds to the same real interest rate and to the same level of spending and output. So the economy moves down the IS curve, and equilibrium moves from A to B, as you can see. So output is now higher, the nominal interest rate is lower, and given expected inflation, so is the real interest rate from the relation between the three. This relation here. Which tells us that if this inflation doesn't change, therefore the change in this will be complemented by the change in that. So these two will move one for one if inflation doesn't change. So let's summarize this effect. So what we've just learned now is that in the short run, the increase in nominal money growth leads to an increase in real money stock. So this increase in real money stock leads to a decrease in both the nominal and the real interest rate, and a decrease in output. Okay, so we'll end here for now. Then in the next video, we're going to look at what happens to this effect in the medium run.